Hey guys, and welcome back. We're going to be looking at linear regression today. So this is a lot in one video. Don't get overwhelmed. I promise once you get it, it makes a lot more sense than it actually looks like. So just follow along. There is going to be another follow-up video that goes step by step through 2 problems. So make sure you watch that. That way you actually know how to do this, okay? So linear regression. We have our key terms, and this is somewhat of an 8th grade thing, which is why we're kind of zooming through the beginning and then really focusing on the algebra part. So our key terms is a correlation. This is the spread of data. So the direction our data is going in. So if I have a graph, first quadrant is typically where we stay. I've got scatter plot points, so just random points. No, they're not in a straight line. They're not connected. They're just randomly placed on the graph. This is usually data over a survey or anything that someone's been doing. So this data, because it is decreasing left to right, that means it is negative. So this is negative data. Let's look at some positive data. So increasing left to right, that would be positive data. And I would make sure that you pause between each word and copy that down. That way you have that in your notebook. Next, we are gonna look at just some random points. Okay. So we have to determine the strength of our data. So not just the direction. Direction is negative, positive, but now we want the strength. So if it is closer to making a straight line, then that is strong data. If it's more spread out, then that's weak data. So this would be considered strong data. If I move these points out though, like this would be considered weak data because it's like all spread out, okay? So let's get rid of these points, clear off our graph, and put some more points. Okay, so now if you look, all of our data is really spread out. So when the data is super spread out, this is actually called no correlation. So these dots just have no connection to each other. My independent X value has no connection to the Y value. So it's just, in that case, in the survey, this data would not be measurable because it wouldn't be accurate. It wouldn't show me anything, just that there's no connection between the two, okay? So now let's look at our line of best fits. Okay, so if we're ever given a set of data, typically we are gonna look at the calculator and see, because we're supposed to utilize technology, but before we do that, you can actually do these by hand too. They won't give you an exact answer, but it will give you an estimate of an answer. So if we have this data, here are your steps. We want to box in the data, draw a line through the middle of the data, and make sure there's an even amount of points on both sides, okay? Once we do that, we'll get into that. So first we're gonna box in our data. So if you look, my box, I'm just making sure it's a rectangle, that every dot is inside that rectangle. No dot is being left out. So next, I do want to draw a line through the middle. And I'm just, if you count just to the best of your ability, make sure there's an even amount on each side. So I see at the top, there's about 10 points. On the bottom, there's about 11 points. And then on the line, there's about 3 points, give or take. So that's okay. So now to find the actual line of best fit, the equation, we would take out 2 points from the pink line and then solve. So this is just, we're not, like I said, this is not exact. This is an estimate, which is why we want to utilize our calculator so that we have an exact best line of fit. So we're going to take out this first point, which is 50-50. This next point is 20-70, about, like I said, not exact, so that's about where they are. So then I'm just gonna find my slope, do point slope, and I see that I get y equals negative 2/3 x plus 100 over 3. So again, that's an estimation. That's not exact. That's just telling me this data, the best line, the best equation for the data so that I can make predictions in the future would be y equals negative 2/3 x plus 100/3. And I can see based on this data, it would be a negative correlation. Probably not super strong, but it would be a negative correlation. So now we have to figure out correlation coefficient. So what does that mean? That is pretty much just where I have, okay, so I have, just think from -1 to 1, what is our data? So if our data is between 0 to 0.5 or 0 to -0.5, that would be considered weak negative. So weak negative and weak positive, okay? And I would write this number line down in your chart because you're gonna be looking for the correlation coefficient and you're gonna have to answer. Is it strong positive, weak negative, or strong negative, okay? Closer, so moving out, closer to -1, closer to 1, that would be stronger. So strong positive if I'm going towards +1, strong negative if I'm looking at -1, okay? So now, how do we find the correlation coefficient and the line of best fit without doing it by hand? Because honestly, sometimes there's so many points and the data it is kind of hard to place your own line of best fit and see where the data lies. So it's just easier if we have an exact answer. So these you definitely need to write down. So we have our steps. So for the Inspire, you're going to list in spreadsheets. You're going to plug in the data, label A and B as X and Y, and go to column C. For Desmos, I didn't write it on here, but you are going to click the link that I will provide, and then you're just plugging in the data to the table that's already there. And on that one, you can literally just press enter and it should give you all your information. It'll be in the next video, so you don't have to worry about that. So for line of best fit, we're going to follow these steps. Go to data and statistics, label X and Y axes, go to menu, analyze regression, show linear mx plus b. So pause the video, write all that down. For correlation coefficient, you're actually, once you do the list and spreadsheet and go into column C, you're actually going to go to the calculator, menu, statistics, stat calculations, linear regression, mx plus b, label X and Y in the list, press OK, and you're looking at R, the correlation coefficient. And I'm actually going to do this with you right now, so just wait till the next video to follow along. Unless you can follow those steps, that's great, but I'm going to do 2 problems, one in Inspire and one in Desmos, so you guys can really follow along. Okay, and that is it. So good luck. Bye, guys.